All right, guys, welcome back. It is time for our next lesson. And this time we're going to be talking about linear models. And in particular, we're going to be talking about the slope of linear models. So let's look at our learning objective. So our learning objective says we will interpret. All right, so let's first think about what interpret means. Any of you guys who speak two languages already know that interpreting means that I'm changing from one language to another. So we're going to be doing the same thing mathematically. In this case, we're going to be interpreting the slope of linear models. Right, now to do that, we also need to be able to identify the slope. So our APK here, something that we should already know is identifying the properties of linear models from an equation. So it says, what is the slope and y-intercept of the linear function y equals -30 plus 5x. And over here I can see that I have slope and y-intercept. Well, when I look at this equation, I see a -30 and then a plus 5, a positive 5, being multiplied times my x term. Now, thinking about what the slope of an equation is, the slope is the repeating pattern of a linear function or a linear model. So the number 5 is being multiplied times x. That has to be my slope because that is the repeating pattern. It repeats however many times I multiply it times x. Then that means the intercept, the number that the linear function begins on or the linear model starts at. So here I see this -30. That's just a number by itself. That tells me my beginning or my starting point, -30 here. All right, let's check out the concept. Okay, so let's look at our concept. To begin with, the definition is the word slope here. So it begins with slope m. M is the variable we use to represent slope in our equations. So slope is the direction, positive or negative, and the steepness fraction of a line. Now, direction and steepness, I think that's sometimes better if I draw a couple extra graphs here to see if we can really understand what that might mean. So let me draw an XY graph here. Right, and we'll go ahead and label that this is our x-axis and this is our y-axis. And let's begin with direction. If I want to understand the direction of the slope, well, if you think about it, when we look at graphs, we always start on the left and go to the right as we read. So I'm going to start on this vertical line, the y-axis, somewhere over here. And what I'm going to do is I'm going to see what are the different ways I can draw a line here. Well, the first off, I can draw it like our example I see to the left. I could draw what we call negative slope line. This line is going downhill from left to right. If I put some numbers on here, maybe we can understand. Okay, well, let's look at a positive slope line. Well, if a negative slope line is decreasing from left to right, a positive slope line would be increasing from left to right. And when I say increasing, I mean moving up, pointing up from the left-hand side of the graph. By the time we get to the right-hand side, the arrow should be higher than when the line started. So this is what I mean by positive and negative of the direction of the slope. Negative, going downhill from left to right. Positive, going uphill from left to right. Just like we read a book is how we should be looking at a graph. Now let's talk about the steepness. Now, the steepness of a line, let's begin again with our XY axis here. The steepness of the line is going to tell me how flat or horizontal a line is, or how vertical or how up and down a line is, or where it is in between. And that's why we have a fraction, because it could be anything in between this horizontal or vertical steepness for our line. So let's just show some examples of the steepness of a line. This would be a very flat line with a small or low slope. Let me just give you a number. Maybe I could say that that slope would be 1/4. See, we can have a fraction that's very small. Let's say we have a slope of maybe a line that looks like this. That one might have a slope of, let's say, 1/2. It's still a fraction, increasing. Let's say we have a slope that goes right through the middle of the graph. That would be, typically, we would think of as slope as +1 or 1/1. So you can see that as I make this line more vertical, the slope increases to bigger and larger numbers. Let's just go ahead and do a couple more. Let's put a line right here in the middle of these. And let's say that the slope of this line, maybe that slope is about 2 or 2/1. And then I can even draw steeper and steeper, in which case that slope is going to become 3, 4, 5, closer and closer and closer until it becomes almost vertical, in which case it would no longer be a function. And we don't use those kind of lines when we're talking about our 8th grade material. So we have the steepness and direction of a line makes up the slope. So steepness, how vertical or flat the line is, and direction. Is it increasing from positive to negative, or is it decreasing from left to right? Let's look at the slope in the context of this problem. All right, so now that we've got some of the slope ideas down, let's actually look at it more in the context of our now that we've got some of the critical ideas of the slope down, let's look at it in the context of what we're talking about today, which would be linear models. So here we can see that linear models represents a data set. It represents it. It's supposed to take the place of a data set. And we do linear models with a straight line. That's where this word linear means and what it represents. Linear meaning straight, a straight line. So let's look at this example and see where the slope, the steepness and direction of this line and what it tells us and how it represents this data set or what the situation is talking about. Let's see here. Student math scores and absences are made into a scatter plot. All right, so when I look at this example, I see that there's a scatter plot here. Scatter plot means that the points are literally scattered around. A linear model of the data has been fit to the graph. Okay, so a linear model, a line, a straight line has been, right here, straight line has been fit to the graph. Okay, so that's this blue line that is decreasing from left to right, starting on the, one of the axis lines. And it says it can be written with as the equation y equals negative 8x plus 95. Okay, so let me go back real quick. A linear model of the data has been fit to the graph. Okay, so this line is my linear model, and it can be written as that equation, y equals negative 8x plus 9. So those two things are the same. That's my linear model. Then the question is asking us, what do the slope and y-intercept, we're going to skip that for this lesson. What does the slope mean in the context of this situation? Okay, so if slope is the direction and steepness of a line, let me look at this graph and see if I can understand what the slope, the direction. So let me look at this line and see what the direction and the steepness can tell me about the situation. Okay, well, I see that the line is starting at about 100 points or maybe a little bit less. Oh, you know what? That must be this 95 right here in my linear model. That must be this starting value, my y-intercept. Okay, well, if that's my starting value, what happens after that? Well, on the left-hand side of the graph, I see that we're talking about points. And on the right-hand side, or sorry, on the bottom of the graph, on the x-axis, we're talking about absences. All right, so I see where I have my absences are increasing. They are increasing from left to right. All right, so that's how the absences are going. And then on my math scores are increasing as they go up the graph. Okay, that's how the math scores are changing. But let's actually look to see what's happening with this slope, this, in this case, negative 8. All right, so I see that the line is starting on the left and going downhill from left to right. So that means my slope is negative. Okay, good, I see a negative 8, so that does make sense. I have a negative slope here. Then I also see that I have an 8, a number that's telling me the actual steepness of that line. Okay, well, what does that number mean in this problem? Well, let's just try to look at these numbers on the x-axis and the y-axis and see if we can figure out what's happening. From 0 absences to 1 absence, I see that we go from this score of 95 to, it looks like there's a lower score. I don't know, maybe that's about 85. Okay, so that makes sense. If I miss 1 day of school, I should expect the number of points on my math test to go down. Okay, well, let's see what happens if we go up another day, if the days increase again. Well, here I see that the line is still decreasing from left to right. So now, instead of being at the original 95, I'm at a lower score, maybe 80 or below 80, maybe 70, 78, 79. Don't know exactly, but I can tell that every time I have an absence, my math score is decreasing. Okay, that makes sense. If I have a negative slope, then that means as my absences increase, my score in math must decrease. How many points I have decreases. That makes sense both in real life situation and also what I'm seeing on this graph. This negative sloped line is showing me that as my absences increase, my scores are actually decreasing. All right. So what we're going to do is we're going to take this idea of using a linear model and the slope of that linear model, and we're going to explain what it means. So the next steps, I'm going to show you how to take a graph and an equation and interpret what does the slope actually tell you about the linear model. Okay, let's try the first problem. Okay, so our learning objective is, again, is to interpret the slope of linear models. All right, so let's read this problem first and see what it's talking about, and then we're going to go through the skill steps and see if we can interpret, explain what we see when we're talking about the slope of a linear model. All right, so first off, it says, step 1, read the situation and examine the graph and the equation. Okay, let's get a feel for what this problem is talking about. Superior Dairy tracks the amount of ice cream they sell each day, like all good businesses should do. An employee compares the amount of ice cream they sell to the outside temperature in degrees Celsius. Okay, so in this situation, Superior Deli sells ice cream every day, and there's a different temperature every day, so somebody's recording how much ice cream they sell and the temperature, probably putting that into a table. He uses computer software to create the equation y equals 30x minus 159. Okay, so now I have an equation from this data set that this employee collected. And finally, the question is asking us, what does the slope mean in relation to the situation in models? Okay, so I have now read the problem. Let's look at the graph though before we go any farther. See if we can get some information looking at the graph. It says number of ice cream sold at the top. On the x-axis down here, the horizontal axis, it says temperature in Celsius. Let's go ahead and label that right now that this is the x-axis. It's always good to know what our axis are referring to. And then our y-axis is the vertical axis up here, and I see that it says units sold. All right, that might be a little confusing. We're not tracking dollar amount here. We're tracking the units sold. Basically, how many ice cream cones they might have sold, how many different servings that they sold in this day. Okay, and then I see that I have some points on this scatter plot, and then I also have an orange line, which would be my linear model. Okay, now step 2. This step is new for any of you guys who have gone through this lesson in one of our prior cycles, and I think it's important to add this step in. It says, explain to yourself what the graph is showing about the situation. It's super common to just jump into a problem without fully understanding what it is that the problem is even showing you or telling you. So let's look at this situation and think through if what we see makes sense with what we expect might happen in real life. To begin with, let's start on the left-hand side of our graph. I see temperature in Celsius, 12, 14, 16, 18. It's increasing. Now, I'm not super familiar with degrees Celsius, but I know 12 degrees has got to be pretty cold. And 24, I believe, is about a pretty comfortable temperature. Now, if I look at the y-axis of this graph, I see that it's counting from 200 to 300 all the way up to 600 units. That makes a lot of sense. They might sell 200 different ice cream cones in a day, or even up to 600, or possibly even more. That's just where our graph stops at. Okay, so now if I understand that along my x-axis is the temperature and the y-axis is the units sold, the graph itself, I see this line moving uphill from left to right. Now, that is my linear model of the situation. And let me see if I can understand what that is telling me before I move on. What I'm seeing is that as I go from left to right, what is happening with my x values? Well, my x values are increasing. They're going up, right? So I'm going from 12 to 14 to 16 as I go from, okay, good. So my temperature is increasing here. Now, what about the number of units sold? Well, as I move up the graph, let me do this over again, maybe show you a little bit better what I'm talking about as I move up the graph. As I move up this graph, as I move up this line, I can see that I am definitely going positive from left to right on the x-axis, but what else I'm going positive with is positive on the y-axis. This line is increasing or going more and more, going farther and farther up the y-axis as the temperature increases. So both of these are increasing together. So as the temperature increases, so does the number of units sold. Does that make sense? Well, yeah, I think that makes sense. If it's like a cold winter day, I'm not going to go out and buy ice cream. I'm going to go buy like a hot chocolate or something. And if it's a hot summer day, then I'm probably going to want to finish that day with some ice cream to cool off. Okay, this makes sense. As the temperature increases, the number of units sold for ice cream is going to increase. Now that I have that general idea of the situation understood, now we can start actually using the equation, using the numbers that they give us to solve this. So let's go to step 3. Step 3 says, identify and label the two quantities, including their units. Okay, the two quantities are the two things I'm measuring, the two things I'm talking about. In this case, we already see that X is the temperature and Y is the units sold. But it's very important to actually write that down. Organize your thoughts, organize what you know about a problem. So I'm going to go ahead and write that down over here on the side of the graph. Let's pick some colors here. I'm going to use X. My X quantity is going to be, it looks like my temperature. Okay. And then for my y-axis, my y quantity, it looks like that was units of ice cream. So I'm going to write units here, units of ice cream. Step 4 says identify the slope. Okay, well, the slope is always the number next to my variable term. That's my repeating pattern. So in this case, 30. This 30 next to the x has to be my slope. Then it says rewrite as a fraction with appropriate units. Okay, so I have to rewrite 30 as a fraction and also include the units. Well, I know I can turn any number into a fraction by simply writing it over 1. But before I do that, how do I know where to put these numbers in these units? Let's go back to our concept of slope. Slope is a comparison of two things that are changing, right? I have to have, in this case, I have my temperature changing and my units changing. Now we agree to always write it the same way, so there's no confusion. The way we agree to write it is that the y units are always on the numerator of my fraction and the x units are always in the denominator of my fraction. So what I'm going to write here, so my y units are actually the units of ice cream. So 30 units of, I'm just going to abbreviate it with ice cream. Now, what about my units for my x-axis? In this case, it's temperature, or I'm going to write degrees Celsius. Okay, now that I have this up here, let's see what it says. Interpret the slope by including the necessary details of the situation. All right, so the details of the situation is we're talking about an ice cream company and how much ice cream they sell based on the temperature. So I need to include and let somebody get that idea by the time from my written description or my interpretation. And it also says I need to compare the x units change, which comes first in this step right here. So notice that I have to interpret the x units change first compared to the y units change. That's going to make these always sound a little bit more intuitive when somebody else reads them or when we write them. So let's look down here at this written example and see how this interpretation makes sense. Well, first off, I'm using part of the question as a part of my answer here. The slope in this situation means, right up here it says, what does the slope mean in relation to the situation? Well, here I'm writing, the slope in the situation means. Now, what does it mean? Well, going back to our graph, we see that as the temperature increases, and in fact, we saw that as it increases 1 degree Celsius, the number of ice cream units goes up. So I'm going to write that this way. The slope in the situation means that for every 1 degree Celsius increase in temperature, notice how I said it had to be an increase because we're talking about a positive value here, a positive one. How do I compare that to the y units? Well, up in the numerator of this fraction of my slope, I see that it's 30 units of ice cream. All right, so now I need to include that and compare it to my change of my x values here. So let me start over at the beginning. The slope in the situation means that for every 1 degree Celsius in temperature, they should expect, superior dairy should expect to sell an additional 30 units of ice cream. Okay, that makes sense. Every 1 degree that the temperature outside goes up, they should expect to sell 30 more units of ice cream. And that's what this graph is showing us. It's showing us that as the temperature increases, so does the units sold. But I can't just say it like that. I need to use the actual numbers that they give me in the problem or in the linear model. Let me circle a couple of things that are key details you have to include. You need to include the numbers. I need to include 1 degree Celsius. I need to include the units. I also need to include 30 units of ice cream here. These are the things that are critical to include in your interpretation. If you don't include those and you just say that as the temperature goes up, so does the sales, that's good, but that's not nearly complete enough. Use the specific information in the problems that they give you. Okay, we're going to do one more of these, and this time it's going to have a negative slope. Right, well, for this problem, we're going to go through the same process. I'm going to skip a few steps so I can slow down on some of the differences about this problem between this one and the last one. So let's begin again by reading the situation and examining the graph and the equation. It begins. A college student collects data on the relationship between sleep and a person's mood. Okay, so we know we're talking about someone's sleep and a person's mood. Okay, it goes on to say, she records the number of hours of sleep, X. Okay, so right now we're already getting pretty important information here. Let's go ahead and circle this. The number of hours of sleep, X, a person gets, and then ask them to fill out a survey to determine their irritability score, Y. Okay, so how irritable. If you don't know what irritable means, it's how easily you might be angry at something happening or how much something might bug you or bother you. And apparently it might be related to the number of hours of sleep you get. Okay, well, let's keep reading and see what else this problem is telling us. She then plots the data on a scatter plot and creates the equation y equals 125 minus 9x to model the data. Explain the meaning of the slope. So here's our question. Let's highlight this so we know what we have to do. Explain the meaning of the slope in relation to the situation and models. Okay, so I now understand that this person is collecting data on the hours of sleep somebody gets and also their irritability score, which I guess you can get a number by taking some sort of quiz or some sort of survey to find out how irritable you happen to be at that particular time. And then we're given an equation, y equals 125 minus 9x, and then we have to explain the meaning of the slope in relation to this situation. Well, let's look at the graph and see if we get some idea of what's happening here. All right, so let's go ahead and label our axis. Our axis line is going to be x for my horizontal axis and y for my vertical axis here. Now, I already see that I have a line on this graph, and let's see, on the x-axis, we're talking about sleep, and I see that the number of hours of sleep would be increasing from left to right, and then irritability score, it looks like it goes from 40 to 90 about on here. Where I think it's safe to assume that the higher your score, the more irritable or the more easily it is to annoy you it might be, and the lower your irritability score, the more patience you might have. So let's see what might be happening in this line. Well, and now I'm actually moving on to step 2 here, trying to make sense of the data here, of the graph, before I try to interpret it. Well, first off, I see that my x-axis is increasing here. So as I follow along the blue line, the linear model, what do I notice is happening? Okay, well, the number of hours of sleep is increasing, sure, but my line is going downhill from left to right. What is that telling me about someone's irritability? Well, I see that I started up here at around 85-ish, and as that blue line goes from left to right, I see that the irritability score is going down. So if the number of hours of sleep someone gets is increasing, their irritability score is going, yeah, their irritability score is going down. That makes a lot of sense. Have you ever got just a little bit of sleep and then everything bugs you the next day? I certainly have. This graph makes sense to me. If I get more sleep the next day, I'm less irritable. I might have more patience. Okay, so what this graph is showing me that the more sleep people get, the less their irritability score is probably going to be. Now that I have that understanding, let's go ahead and start writing down and explaining what the slope is very much explicitly telling us. Step 3, identify and label the two quantities. Okay, well, let's go ahead and keep our colors consistent here. Our x value, the x units we are talking about, is hours of sleep. Okay, hours of sleep. Now, the y variable, what that's telling us is our irritability score. So I'm just going to write score for short here, since I can't even spell irritability and it's a really long word, but I'll make sure to include that when I can in the important part of our answer. But Y stands for our irritability score. Okay, step 4. Now step 4 says identify the slope and rewrite as a fraction with the appropriate units. Okay, so again, I'm going to remember that my numerator is my y units and my denominator is my x units. Okay, so my slope is going to be m for slope equals. Let's put my y units on top. Wait, skip a step. What is my slope? Oh, this is a critical step. Slope is always the number next to my variable term. It's the repeating pattern, so it has to be next to the x term. So y equals 125 minus 9x. Something seems odd. You know what? The x term is second, but that doesn't change how to identify the slope. The slope is my number next to my x variable term, so slope is -9 here. Okay, so if my slope is -9, let's go ahead and put that -9 in my numerator here. And then that means I can always turn -9 into a fraction, -9 over 1. And then now let's include our units. -9 would be our irritability score. Let's go ahead and say, I'll try to write it. Irritability score. Wow, that is just, I think I can try that one more time. I don't think it's going to be any better though. Wish me luck. I forgot how to spell irritability. Got it. Irritability score. I don't know if that is any better, but that is just what we have to work with. Okay, well, now what is our x units? Our x units along the bottom of that graph is sleep in hours. Okay, so 1 hour of sleep. Okay, so my slope here, let me go ahead and kind of box this off and separate these two things for you so we can see what my slope here is. My slope is -9 to my irritability score over 1 hour of sleep. Okay, let's connect that to what the graph was showing us, that the more sleep we get, okay, 1 additional hour of sleep, what is that going to do to my irritability score? It's going to decrease it by 9. Oh, all right, so now instead of just saying like, oh, as the more sleep I get, the less irritable I am, now I can say with actual numbers, 1 hour of sleep will make my irritability score decrease by 9, let's say 9 points. All right, well, let's go ahead and write that and see what our sentence should be. Might look like this. All right, let me go ahead and erase some of this for you guys so we can see it. Now, in, to now to interpret the slope, I'm going to make sure I do this in the same order as last problem. I'm going to compare the x units change, what happens, and how do the x units change compared to the y units and how those change. So we're always going to start with the x units and then the y units will follow. So let's see that in my response here. The meaning of the slope in this situation is that for every additional 1 hour of sleep, so every additional 1 hour of sleep, that's my x value here that I'm comparing first. Well, what happens if I get 1 extra hour of sleep? My irritability score goes down by 9 points. So let's see how we might write that. The meaning of the slope in this situation is that for every additional 1 hour of sleep a person gets, they can expect a decrease in their irritability score by 9 points. Okay, now this is something I just need to explain very quickly. Notice in our slope that it was -9. Well, look how I put 9 points here. Why didn't I include the negative? I actually did, but I did not write it as a negative number. I used a word. So this word right here, decreases or decrease, that is my negative sign right here. So I can say they can expect a decrease, negative, in their irritability score by 9 points. Now, this lesson was about interpreting the slope of linear models. So that's what our independent practice is going to be. And I encourage you to try the independent practice. And if you feel like you've understood it or don't feel like you've understood it, come to class tomorrow, come to class the next day, because we're going to go over this topic again, because we have seen this is not something that is simple, and we want to give everybody the most help possible. So please come to class tomorrow so we can talk and sort out any questions you might have about interpreting the slope of linear models.